Well, that was super embarrassing because I just recorded this entire episode and I guess it didn't show up in my YouTube. Crying shame. Anyways, back with week 3. We're talking. You know what? That's a good thing because the last one I really screwed up at the beginning. So this is good for both of us. Let's just do it again. So one of the things we've got to knock out right off the bat, it comes up here and it's come up before in other books, is it's expected that as we build software, our understanding of what we can do and what we should do evolves based on what we learn while we're building it. And there is a major differentiator between good software teams and low performing software teams. But in order to understand whether or not we are a good software team, we've got to measure our performance. So, we've just got to understand, what does good actually mean? And this isn't a new concept. This is a concept that's probably been around since we've been developing software. We have these metrics in place or these measurements in place to determine whether we are performing at at an acceptable level or what. It's why we run leak code and interviews to measure whether somebody on their way in is a good developer or not. Now, there are obviously questions that need to be answered about whether or not leak code is the indicator. But anyways, that's not the important part here. So most measurements focus on productivity traditionally, which has a number of drawbacks. First of all, it focuses on the outputs as opposed to the outcomes, and we'll talk about what that means in a moment. It also focuses on individual or local measures of productivity rather than global ones or team level things. So some bad examples of measurement systems, so things that have been used in business but are not particularly good measures of software team delivery or ability, is so the authors provide 3 examples. The first we don't even really have to get into, but it is true that at one time in the history of software development, lines of code, daily production of lines of code, was used as a measure of how productive your software is. It's laughable now, but there was a time when that was the system they used to measure how good their programmers were. With the advent of extreme programming or agile programming, the measurement systems started moving towards focusing on something known as velocity. And if you are unfamiliar with agile processes, the way this stuff works is you get a list of tasks or tickets that need to be done, software development tasks that need to be produced. And you'll get your team together and everybody will say, how long is this one going to take? How long is this one going to take? And you sort of estimate the time it will take to finish each of these tasks. Well, then at the end of your sprint or at the end of your measurement period, you go back and you see how many points you got versus your estimate. So the problem with using velocity as a measurement is as a metric for measuring software performance is it doesn't actually directly serve the bottom line of the company, in that teams can game these metrics. For example, teams could start to come to sort of a tacit agreement that they will estimate things a little higher than they would before. So, everything that used to be 2 points is now sitting around at three, and so it suddenly looks like their team is producing at a much higher volume than other teams. But one of the other things is you could grab a cluster of tasks that are easy to knock out and finish and clear off the board, but they don't serve the bottom line or outputs quite as much as delivering on that large, big feature, right? And so that's the argument around why velocity isn't necessarily the best measure to figure out whether or not your software development team is performing as expected. So the next thing that we would talk about in that space is something called utilization, or the number of hours within an 8-hour day that your programmers are spent writing actual lines of code, or on something, maybe you would have it on billable work. Now, the problem with pushing utilization as a metric is it's virtually inevitable within a software development lifecycle that things come up that are unplanned. And if you are at full utilization, you don't have anybody to pick up that slack work or those things that came up that are particularly urgent, but you just don't have time to do it because you don't have anybody around to do it with space. So, with that said, we should talk about what successful performance measures look like. And so successful performance measures will focus on global outcomes. Okay, so rather than individual tickets, they will focus, let's say we expand it to a team effort, and we will say it's not about these individual tickets, it's about delivering these features, right? But on top of that, successful metrics for measuring software delivery performance will make sure that teams are not pitted against each other, but instead have incentives to work together to push the software product forward as a team and as a group. And they focus on the outcomes, not the output. So it's not about lines of code. It's about whether the feature works and whether it's maintainable. And successful measures should also not reward things like busy work and toil. So those are all the features of good metrics. And the book has come round to discover, I'm going to switch over to, again, we've mentioned these before, but these are the good metrics that we've found. We've found delivery lead time, so the amount of time it takes to go from I've pushed my code into the mainline branch of my source code repository to the code is out live on a production server and customers are currently using it. The deployment frequency, the number of times a day that you can do that. We know that systems go down. It's inevitable that systems go down. And so the time it takes to restore service after chaos comes into the works is one of the metrics we're looking for. And the change failure rate is one of the metrics we're looking for. So shorter delivery lead times are better because they allow for faster feedback. The sooner you can get things out in front of your customer, the sooner you can find out whether they are delighted or whether you should maybe roll it back and think about something else. So one of the digressions that comes out into the book, but it's very good. It was a very good illustration. It helped me understand what was going on. Is this term batch size? So batch size is given to us as an example from the perspective of a Toyota factory. You imagine your car assembly line, and a batch size is the smallest number of cars that you can profitably produce given the cost of retooling your machines. So you're switching from a Toyota number one to a Toyota number two, right? And how many machines do you have to change? And how long does it take to make you change those machines? And how many cars have to come off the assembly line before you say, okay, we've made enough to make it worth the time we put into changing the machines. Let's change them again, make up the next type of cars. So this is a well-known metric from physical manufacturing, and the proxy that we have, the thing that is most analogous to software batch size, is the deployment frequency. So the number of times we can launch our website, our product within a day, is or the frequency with which we can get a new version out. That would be considered our batch size. So when you take delivery lead time and batch size and deployment frequency together, that would represent our tempo, the tempo of our development. The other feature that's important, the critical features around, so we've got our tempo, but there's also, again, remember that chaos happens within our systems. It's inevitable that something goes wrong in software. So how quickly, when we have made an error, can we get back to a good and working state? That's one of the metrics that we're looking at. And how frequently, based on our deployments, how frequently do things actually fail? And so I reproduced a chart from the book here, and we'll bring that up here. And we say, so high performers will have multiple deploys per day in terms of the deployment frequency, whereas low performers will be able to launch maybe once a week or maybe once a month. They have their launch day, right? So the amount of time it takes to get something from mainline into production for high performers, it's less than an hour. For low performers, it's between a week and a month. Again, it's related to their deployment frequency. You get this stuff in. When things go wrong, how long are things bad for? Less than an hour, you figure it out, you revert the commit, you push back up again, bam, everything's working. To, man, it took us a whole day, to it took a whole week to figure out what went wrong on the deployment. And finally, how often do things go wrong on your teams? 15% at worst for high performers, to as much as 30 to almost 50%. 50% of the time things go wrong. If this is happening to you at your employer, just go somewhere else. Don't even try to stick around. You can do better than that. You can get on a better team. Stop learning bad habits. Quit your job. No. Or actually, because we have said that software delivery teams, anybody can improve. Make sure that you focus on trying to improve, but also consider moving on where you can work with a team that doesn't suck. Anyways, so that was not nice. Okay, so the interesting thing about the findings that we're coming up with here then is that there is in fact no trade-off between speed and failure. You in fact, higher performers not only deploy more frequently, they get their stuff into production faster, they fail less, and when they do fail, they recover faster. So it appears to be the case that the robust and solid systems to make us deliver quickly our robust systems around testing and recovery are required to go fast. And all of these things around DevOps are what make the difference between a low performer and a high performer. And in the studies, the authors are finding that over time, high performers are moving further and further ahead, and low performers are falling further and further behind. So really interesting stuff. So the next piece that we want to talk about there is the fact that there's in fact the strength of the findings are so strong, are so pronounced, are so significant that they've moved beyond just simple correlation. It's not just a correlation, but in fact there is a predictive relationship between engineering performance and organizational performance. Organizations with high performing information technology teams are more profitable. They have a greater market share and they continue to capture more and more of the market. And they are higher productivity overall. In fact, high performing organizations are twice as likely to exceed their goals around shareholder value and return on investments as low performers. So twice as likely to perform well financially. High performers also are twice as likely to exceed their objectives on things like the quantity of goods and services delivered, the operating efficiency of their organization, their customer satisfaction, the quality of the product they produce, and achieving their organizational and mission goals. So high performing orgs, almost by definition, high performing, they're performing high, they're performing well. But here's another reproduced chart that we have here. And again, really want to stress this part, that this is predictive. This is not simply correlation. If you have a high performing software delivery team, you will be able to, you can bet on the organization with a higher confidence, not just for organizational performance, but for non-commercial performance as well. Really important. This stuff really matters. Now, what do you do with this information, right? Okay, so I understand this. I now am in a position to understand that I need good IT. So what do we do? This is a strong case that gets laid out right here to say, if there is software at your business which is strategic in nature, so it is something that drives your core business, do not outsource that key software. That's the important stuff. The cornerstone of the core pillars of your business have to be built in-house, right? You are not outsourcing that. What it does, however, mean is you should also make sure that you are not building software that is not core to your business. And that could be things like ticket management systems, payroll systems. Don't go out and try and build Microsoft Excel. Just buy in Microsoft Excel. If you have a business, don't use Google Sheets. It's nothing beats Excel. Just get Excel. Stop trying not to use Excel. But anyway, so unless you are Jira, you're not building your own ticket management system, right? Unless you are ADP, you are not building your own payroll system. Unless you are Microsoft, you're not building Excel. Just buy the existing Excel. So the question then is, so what we have to do, we have to distinguish between our strategic software, the stuff that is core to our business, and the non-strategic software, stuff that we could build, but it's really just not part of the business that we're in. And there was a mention of something called, I'll bring up the notes here, the Wardley mapping method. We're not going to go into detail here, but some of these links, this one in particular, the InfoQ presentation, has an interview with the gentleman Simon Wardley, who is the namesake of the Wardley mapping method. And the crux or the thrust of his presentation is to say that you can sort of draw the relationships of the software that you could write next to the business the business goals that you have, and you sort of draw them out at a distance, and the distance between the strategic value of the business goal and the software that you have to create for it tells you which ones to concentrate on. Follow up on the topic. It is really interesting. It is very good. It's well worth learning about and figuring out, how do I come up with a strategic method for deciding what our business should focus on. So the findings in Accelerate, what is this? This is sort of the conclusion of the chapter. So we're almost done at 20 minutes. Okay, that's good. So the findings in Accelerate are about moving beyond simple correlations and into the realm of prediction, but there is a warning at this phase, and it is a bit foreshadowing for the next chapter. So the warning at this phase is, you have to have the right culture to adopt measurement methodologies within your business. And the reason for that is, if you're in a learning culture, in a high feedback culture, but a high psychological safety organization, it's okay to be honest about things like your productivity and things like that, because people are not afraid of what happens to them if they just tell the truth about their performance. But if you are in a pathological type of organization, something that is highly bureaucratic, or if you are working on within a culture of fear, or in a place where measurement is used as a tool of control, think about places that have PIP cultures, is a PIP, performance improvement plan cultures, where that's used as a blunt instrument to try and make your development team work harder, and they are not, and they are used in a sort of manipulative power dynamic sort of way, or there are organizational quotas around the numbers of performance improvement plans that have to be handed out, or there are organizational quotas around the number of people who have to be fired from any team. We could talk about Microsoft in the early 2000s had a stack rank where the developers on a team were rated from 1 to 10, and 1 was the best, and they were rated like a stack, and then Microsoft, and it would say, well, and the bottom 3 in the stack get fired, right? So what happens when you build these cultures of fear is people start gaming the metrics. They might inflate their estimate for their story points, for their velocity countdown. They'll say, oh, this is going to be a 3-week task. It's really hard. Oh, it's so difficult and so challenging. And then, they only took a couple of days to do it, but realistically, it's because it was only ever a half-day task, but they just want to make sure that they have all of this buffer zone, and they can play it safe. So the concept is that we have to have psychologically safe organizations, and the the tools that we're talking about and the culture of the company that we're working in is highly critical within the process of building a high performing organization. So hopefully this one recorded this time, because I just went through that a second time. I did a much better job, so you're lucky. I'm lucky. I'm actually lucky because the first round was crap. But anyways, that's it for this round, and we will talk to you again soon, where we will talk about culture and measuring culture and how culture impacts your engineering performance. So your engineering team performance. So thank you very much, and we will talk to you again very soon. Bye.